question here. What would be helpful to look at in regards to that test if you want to look at stuff from it?
Could you tell any questions that were like very obviously commonly missed?
It does actually give me a nice breakdown. I mean, I know what I think from going over them, but let me kind of try to compare that to the actual breakdown. There we go. Let's see. Relative frequency from distribution table was the most missed. So yeah, let's go ahead and look at that. And this is one of those questions that we talked about a number of times before the test, because it does tend to be a question that can be a little bit tough. So I'm just grabbing a random one. So relative frequency from frequency tables can often be a little bit icky. So that one we should probably look at. What else? The Z-score question, a lot of people miss stuff about it. So, but for a particular reason. So I want to look at that just from a kind of a test taking perspective. So I think that's a good one for us to look at. But if anybody remembers one that they were like, that question drove me nuts, can we look at it? Let me know.
Sure. After this one, actually, I thought I knew about the empirical rule. I apparently don't, because I got it like almost entirely wrong.
That doesn't necessarily mean you don't know about the empirical rule, but which question was that? I can't find it.
Oh, it was asking for the breakdown in percentages, like where a certain value, range value was, and what percentage of the total data was there.
Oh, there it is. Okay. Yeah, I was just trying to find it on the list. So.
Oh, also, can you do the one that was like, it like started with the IQR, and then it went to standard deviation, not that part, but the second part where you had to find like a range between like a minimum and maximum. Those two bottom rule ones, I struggled with that.
Yeah, that's definitely on my list of ones to look at. And I think that one, there's just a lot of pieces to it. So I think there were a good handful of people who got all of those right, but most people had something, big or small, something come up on that question where it was like, and a lot of them I think were just kind of like, whoops, but there were certainly worth looking at. And I'm grabbing ones from the test, but I'm not grabbing any particular ones from any particular test. I'm just grabbing, so they will be slightly different value-wise. And I do want to grab this one as well, just to look at it. And again, if I happen to grab yours, I apologize if anything, I certainly won't. I'm trying to make sure there's nobody's name on anything, but I'm not picking any of these out particularly. So I do want to talk about the individual variable sample one, just from a kind of a, what were you looking for perspective? What was I looking for perspective? Okay, so let's look at these. So the frequency distribution one was, as I said, probably, I think it had a 62% rate. So 62% of people got it right. And that was on the lowest percentage correct rate, which is actually not bad. I mean, that's always a good sign. If you have a question where, you know, only 20% of the people get the question right, and then you're kind of like, okay, that something's wrong with that question, you know, or something's wrong with what we talked about for that question. So 62% being the lowest question score means we're probably okay, particularly for this question, because it does tend to get a fair amount of points, a little bit icky. So based on the frequency distribution, find the relative frequency. So that's a proportion for a class with a lower class limit of 27. So we go up here and look for a lower class limit of 27. That's this class. So we're asked for the relative frequency of that class. So we've got to say, okay, how many individuals are in that class? There are 8 individuals in that class, and 8 out of how many total individuals were in our sample here. So we've got to total all this up to figure out that that is 8 out of how many. So what was it, 10, 20, is that 32? 10, 20, and 12, so 32, yeah. So 8 out of 32. So 8 out of 32, what is 8 out of 32? I don't have, where's my calculator? Oh, there it is. Oh, it's a quarter, isn't it? 32 is a quarter. So 0.25. They weren't all nice numbers like that. And I think, as I recall, there was a percent and it had a box, right? The relative frequency was, so 25. Type only, yeah, ask for the percent round to 1 decimal place. So there were some people who like how much they rounded was an issue, particularly when it wasn't that nice of an answer. There wasn't too many issues with rounding that I saw, but there were some people that, you know, I gave points back to because, you know, some points back to because, yeah, that's more or less the right answer, but you got to pay attention to how much you're rounding. And there were a lot of fairly easy places to make mistakes here. One is if you just added that together wrong. Sometimes your answer was a little bit off. You know, I tried to give points back for if it looked like that's what happened. But that relative frequency, that part out of whole, as we get ready to go into chapter 5 and start talking about probability, this idea of part over whole is going to become real important, because those are essentially going to become our probabilities. So if we wanted to start thinking of this in terms of probability, like why would somebody want that relative frequency? If you grab a random student, what's the probability that they will be between 27 and 30? Well, that relative frequency is the probability. So our beginning sections on probability will mostly just be about taking these things that we know how to calculate and turning them into the vocabulary of probability. Does that make sense? So, you know, this exact question translated into, you know, given this frequency distribution, what is the probability of an individual being in the lower class, in the class with a lower class limit of 27? It's the same question, but it becomes a chapter 5 probability question as opposed to a chapter, you know, 2 or 3 relative frequency question. Fair? All right. The results of the case, I'm going to go over to here to the E-score question. Move that out here. Calculation wise, most people were okay with this. So the results of a common standardized test used in psychology research 2008 designed so that the population mean is 135 for this particular question. The standard deviation of 10, subject earns that particular score. What is the z-score? So finding the z-score, we find the z-score by taking the value minus the mean and dividing by the standard deviation. That's how we compute a z-score. So here, if our standard deviation being 10, the 131 minus 135 divided by 10 certainly does give us a value of -4 over 10, certainly does give us a value of -0.4. In the scoring, this question was worth, was out of 6 points. How many out of 6 points do you think this answer got?
One.
I'm not that mean, am I?
Oh,
But I like the idea that the expectation of 1 and I'm not that mean means you guys can't be too mad at me.
the bar is pretty low.
So that's good. I gave the answers like this usually 3 out of 6. Some of the answers were, a little bit more elaborate, but similar. They would say things like, you find a z-score by taking the value, subtracting the mean, and dividing by standard deviation. In this case, the value would be 131. You would subtract that from the mean of 135, divide that by the standard deviation of 10, yielding a result of -0.4. That answer is still 3 points. Sorry, my camera wasn't on. If somebody wrote the z-score is -0.4, that's also 3 points out of 6. If you wrote the answer -0.4, and that was all you wrote, okay, that was usually 2 points because it told you to write it in sentences. What's missing for all of this?
Interpret the meaning.
That interpret that. What does this mean? What does this represent? And there was a fair amount of variation. Some of them, you could kind of tell what you were. I could kind of tell what you were trying to say. Some people were working harder than necessary to try to figure out what to say. But something that expressed that this means, or that that the value is 0.4 standard deviations below the mean. Now you could have said -0.4 standard deviations from the mean. That would be fine. There were other people who were saying things like it's lower than the mean, but by less than 1 standard deviation. So it's a typical value. That's an example of somebody that's all true, kind of working too hard trying to answer this question. And I think I gave that 6 out of 6. You know, that's a very, you know, that's, but that's is working a little bit harder, you know, than necessary. Just saying it was below the mean is a little bit less, but correlating that value to a number of standard deviations is the key. Fair? So look at how you answered that and kind of go, okay, you know, what might have been good or bad about that? And if you have any questions about that, let me know. But something that indicated that this value was the number of standard deviations below the mean or above the mean or from the mean is important there. Let's see. These questions were a lot of work. Let's look over here. So before we do that though, any questions about that? For z-scores. As I mentioned, z-scores are going to come up more often, but it takes a little bit of getting used to what does he want when he says interpret the meaning. So that can take a little while to get used to. I do try to tell you guys, you know, but that a lot of times math hasn't prepared you for, you know, describe and interpret what this means. So that's going to happen to us a fair amount. So getting used to that and what do we want is important. Okay. We prepped this question a fair amount. We did a couple of them, but you know, we did it together a fair amount because it can be a little bit tough. One of the things that we focused on is kind of trying to turn this into a nice diagram with those empirical rule percentages on it. So you could have done this with the straight empirical rule, the 68%, 95%, and 99.7%. Or you could have done it from the perspective of breaking the pieces into their different little chunks. We did it kind of both. I think we broke it into the chunks more often, but that was what, 34%. These were 13.5, as I recall, %, 13.5%. These little pieces were the hard ones. I often think of those little pieces as, you know, how much is out here? How much is out here is the 0.3%. So on each side, it's 0.15% if you divide it by 2. So if that's 0.15, how much has to be left here? Well, of the 2.5, percent that's outside of the 95% on both sides. If we take out that 0.25, then there's got to be 2.35 in there. And we looked at making this diagram in a couple different ways. You can look back at some of that in the videos if that's helpful. But we did try to build these pieces. Anybody terribly unhappy with those pieces? And most of the issues, I think, tend to come up with these, you know, two, like when to think of them as one piece being the whole 2.5, and when you've got to account for that 0.15 that's either in or out. And I think that's where a lot of the issues tended to come in. But if you've got that diagrammed out, and again, I do, and I have stressed for you guys, draw diagrams, then you can kind of highlight it and figure out where you are and then add up those percentages. So what is the approximate percentage of buyers who paid between the 1320 and 1600? Well, 1320 is there, 1600 is there. So you are that group. That group's going to be the 34 plus the 13.5. So the 34 and the 13.5 is going to be the 47.5. Now, did they get this question horribly, horribly wrong? No. They were close. And I think I'm sure I gave some partial credit for that. If I didn't, let me know. But you can imagine that if you went, I think one of the common answers to this particular question was 50%. But of course, there's these chunks missing out there, right? So you could have done 50% and then subtracted that. That would have worked too. So really, the rest of these questions are all just about, you know, which groups you're in and which and what you're adding together. Between 1460 and 1750, well, that's one standard deviation from the mean. So that's that set, which we automatically know is 68%. Where's one of them that's fun? This one's a fair amount of fun. Approximate percentage more than 1800. So more than 1800 isn't just this section from 18 to 220 or 2020. It's that whole section all the way out. So it includes both the 2.35 and the 0.15. Let's see. What about this one? What happened here? Was the approximate percentage between 16 and 2020? Well, between 16 and 2020, is this set stopping there? So that should almost be 50%, but 50% minus that little piece. So that would be the 50% minus the 0.15. Or you could add together those three if you want to. Either way, you'd end up with what, 49.85. Let's see, less than 1180. Less than 1180 is that piece. So that's the 0.15. So how much of that is having this diagram nicely made out? I think a fair amount of it's having the diagram nicely made out. But is there anything particular about that that you guys are fighting with, or, you know? David, I think you asked about that.
Oh yeah, I actually just I realized my mistake. I didn't until just now when you wrote the whole percentages out. I just misremembered some of them, like 2.5. I remembered it as 2.15, and so it all just threw me off.
Well, I think that's one of the reasons that I recommend don't like memorize those 6 boxes. Those 3 numbers build everything else. And I think that's easier. We often try to memorize too much and don't build enough. If you learn how to build pieces, you can reduce the stress on your memory a lot. There'll be a couple things we do later that your book will have like 4 different formulas for, that we don't need 4 formulas. It's one formula and then solve. And each of the other formulas are just solved versions of the first one. Like you don't need to memorize all these formulas. You need this one relationship, which actually, which we also technically don't need to memorize because it's another relationship we already use. But a lot of people are just like, what's the list of formulas I need to know? And over memorizing can be problematic. But yeah, it wasn't too uncommon for a lot of these numbers to be close for reasons like that. So I tried to throw some points in those directions, but that depended. So anything about those before we look at the IQR one? IQR one takes a little bit of time to go through. Okay. This was also not an uncommon question to have be just a little bit off, or anywhere between a little bit off and a fair amount off, just from a perspective of did you type it in right? Did you copy it down right? Kind of issues. And again, I try to compensate for that a fair amount. You certainly could have done this problem by hand, though that would have been time consuming and painful. But you could have put it in your calculator. That would have been fine. I'm going to use Excel so you guys can see what I'm doing. But I can't copy and paste that from there. Don't make me type it in. Fine, I'll type it in. 326.5. Read that off to me. What's better, nobody reading it off or everybody reading it off at once? That would have been horrible.
All right, I'll go for it. You ready?
Yeah.
So 0.5, 615.4, 673.8, 451.6, 579.1, 456, 658, 56 or 563.3, 446.5. 5.
I know, but one of the things I want to show you, and we talked about this, but just to kind of remind you, it's really easy to make a little mistake like that in typing it in. If you're good with highlighting stuff and copying and pasting, it can be a little easier. But particularly typing into the calculator, it can be really easy to have that kind of come up as an error. And that's one of the reasons they tell you this sum, that checksum, is there so you can check, do I have this typed in? So, you have a list in the calculator, have it do the sum of that list, see if they add up right. If you're on Excel there and you have the whole screen, and you highlight your list, it'll tell you your sum down here at the bottom. Or you could just go auto sum, and we'll add them together. And you go, okay, 73.16.6, 73.16.7 or 4, I got that wrong. What did I type in wrong? And you go back through and you go, oh, wait, there it is. Now those match up, so your data should be in there right. So if you're ever wondering why they give you that checksum, or how do I make sure I don't make that kind of mistake, that's a nice way to do it. Use that checksum. So from there, we could start by finding the means and medians and whatnot, but I'm going to put the data in order first just because it's handy. So I'm going to go to the data and sort. So, okay, now the data is in order. That's nice. And we could calculate, you could use that data analysis tool, but I like to break it down. So I'm going to find that average. Remember, Excel uses average for mean. So now I'm going to label it so I don't lose track if I can manage to type. So that's our mean. Median, you could use the median finding tool, or just, we know how many data points are here. There are 13. So 13 means we're going to have 6 on top and 6 on the bottom, right? So we could do it because it's a short list. We could just, kind of brute force it out, but there is also a median tool. So we could have it tell us the median, and then, oh, it has to be that one. It's often tough if there's multiple values, that median, like which one is it? I told you guys to be careful about the quartile tools, right? Because there's the whole excluding and including and excluding issues with the quartile tools. So finding the quartiles using your median does tend to be better. So finding Q1 and Q3 by finding the median of these lists is a lot better. So you could either use the median tool again on those lists if you wanted to, or since it's a short list, you could go, okay, it's the average or the mean between those two. I'm gonna do both. I'm gonna say for that one, find the average between those middle two. That's the add up and divide by 2. Take that quartile. Or you could say, find the median of that list. Should be the same either way. Fair? Notice it has that little triangle up in top. That triangle is a warning. It's saying, is that what you actually wanted? Because it's noticing that this column and that column, or this cell and that cell, are both referencing this entire list. And this cell is only referencing part of the list. So it's going, is that what you meant to do? By putting that little warning thing on. And yes, it was what we meant to do. So it's not worrisome. Now, if I drag that down, well, that's using what, B5 to B10, because we drug it down, B5 to B10. I don't want B5 to B10. And of course, I don't have to do it this way. You can do it just the way you did before. I want those. So however you want to go about doing that, you can find those quartiles. This is going to be a common issue with Excel. Like, what is the way to find these on Excel? There is no answer to that question. What are somewhat different ways to find this on Excel? That we have answers to. So that can often be a little bit tough if you want, like, what is the one way to do this? There isn't a one way to do it. So I'm going to try to give you guys options. Your labs are more like, here's this method. So it's going to be a little bit more do it this way. I'm going to be trying to show you guys flexibility and options. Questions about any of that? If we want the IQR, we could type in, take this and subtract that. But again, this is Excel. Excel is all about references. So take that cell and subtract that cell. That's your IQR. That way, if your data changed for any reason, it would automatically change in computing that IQR. So cool, we got an IQR. So this IQR over here, the 108.5, why is that wrong? It's small for some reason. And I don't know why. I'm not sure where that 108.5 came from. And oftentimes with these, I could kind of figure out, oh, okay, that's happening for this reason, or somebody added it to the mean or median. But oftentimes it was just, I'm not sure where that number's coming from. So sometimes that was tough. Let's see, we're also going to need standard deviation. So again, equals ST, this is a sample, so I want ST-S. I'm gonna highlight all that data. So we might have thought, okay, I don't need the mean yet, but later on we will need that mean, so it's nice to have it. We don't actually end up using the median for anything else, but using the median to find the first and third quartiles is a nice way to go about finding the quartiles. So that gave us the quartiles. We need the quartiles to do the outlier question and to figure out what our outer quartile range is. And it both asked us for the standard deviation and makes a standard deviation question later. So we need all those little bits, but I think that's all that we need from our data. Questions about any of those before I look at how we answer these questions?
Just raising my hand a little bit. It's not about this, but will we have time to discuss lab 3 just for a couple minutes?
Sure, likely, yeah.
Awesome.
Okay. Let's see, where was I? Okay, yeah, so that's just gathering our information. The IQR we found, sample standard deviation we found, that's the 110. Again, this looks to me like, okay, because these are all, I think as I recall when I went through these for this particular question, they were all like relatively close. So I was kind of like, okay, it kind of feels like somebody typed something in wrong, you know, or missed a number or something like that. And I, again, tried to give some points for that, kind of like, okay, you know, these numbers clearly aren't coming from nowhere. So I tried to kind of figure out what was going on and give some points back. If it looks like I was like, if they were totally off and there's no points there, but you're like, hey, this is how I found that. Can I have some points? Let me know. And sometimes I can give a point or two back. I'm always happy to talk to you about it. Anyway, the 1.5 IQR rule for outliers. Do you guys want me to do this on Excel or by hand, by the way? My tendency, since Excel's here, would be to do it on Excel, but.
So
What's that? Nathan?
Excel.
Excel, okay. So our 1.5 IQR rule, since if we're going to do it on Excel, it might be nice just to know what that 1.5 times IQR is. So let's have this cell equal 1.5 times IQR. Labeling is really handy, by the way, especially if it lets you. Oh, that put equals. Don't want that equals yet. So I'm just labeling, I'm going to make that cell our 1.5 IQR. So equals 1.5 times, and I'm just going to click on that IQR. And again, now if anything changes, I can, you know, it'll automatically update everything. So if we want to know, so that's our 1.5 IQR. We're not asked for that anywhere. But remember, our lower and upper bounds are found by taking our, say, our Q3 and adding the 1.5 IQR. Sorry, that should be Q3. And again, we have all those pieces. So equals Q3 plus the 1.5 IQR, which again, I could just type 1.5 times and then reference the IQR cell. But since I found it there, I can just use that cell. Didn't need to have that extra cell in there, but you know, if it keeps me organized, awesome. So that gives us the upper bound. Again, I can label that upper. The lower is going to be that Q1, the low Q1 minus that 1.5 IQR. So 1.5. Keyboard's not in a very handy spot while I do this. So equals IQ1 minus the 1.5 IQR. And that gives us the lower. So 217 and 888. You started to get a little further away. I think part of it was this IQR, but I don't think it accounted for all of it when I multiplied it out. So those are our upper and lower ranges. But if you are using Excel for these, and Excel's a nice tool. I recommend learning to use Excel. If you're like, I don't like using Excel because I'm not comfortable with Excel, get comfortable with Excel. It'll make your life better, easier, happier. Flowers will bloom at your feet as you walk.
What kind of flowers?
Digital flowers.
Okay, that's pretty cool.
Thank you. What kind of flower? Sunflowers. Is that cheap? A little cheap. All right. I don't think there are any other flower, nicer flowers. Nope, that's all I got flower wise. Okay. So that's for the 1.5 IQR. Then are there any outliers based on that rule? Well, is there anything more than 888? No. Is there anything less than 217? No. So no. Then the 2 standard deviation rule for unusual. Here we have to be careful because remember, the standard deviation rule isn't based on those outer quartiles. The standard deviation rule is based on the mean. Standard deviation and mean always go together. It's even a little bit kind of emotionally difficult for me to see this mean and this standard deviation with all this position stuff in between. I like emotionally want to go, the mean and standard deviation go together and the median quartile IQR stuff goes together. And I don't like them, mixing this much. That might sound prejudicial of me, but it's good to separate them kind of logically. These are 2 different sets of tools. Mean and standard deviation are our value-based tools, our median, quartiles, interquartile range. This is position-based tools. Fair? And I know I've stressed that, but sometimes, stressing that and then working with stuff for a while and then getting back to stressing it again can help it. You kind of make a little bit more sense. So our 2 standard deviation rules for unusual really wouldn't have had to have said 2 standard deviation rule for unusual. Unusual refers to 2 standard deviations, right? If you're unusual, you're 2 standard deviations from the mean. So this question was kind of being helpful. So if we wanted that, again, I'm going to label these unusual. Well, I'm going to say unusual high and unusual low. Unusually high is going to be adding 2 standard deviations. Unusually low is going to be subtracting 2 standard deviations. But it's important that that adding and subtracting happens from the mean, not from the median, not from the quartiles. So equals that mean plus 2 times that standard deviation. And then our mean minus 2 standard deviations. Oops. I forgot my times. Times 2 standard deviations.
So that means we can have unusual data that are not outliers, right? Because there's
Absolutely.
a range between 782 and 888.
Absolutely. Completely. In this particular data, is there anything that was unusual? Well, yeah, that 862 was unusual. And, you know, as you were asking, it's unusually high. It's not an outlier, but it is unusually high. Unusual is not as restrictive as outlier. As I said the other day, we were talking about this. I am in height, I'm 6'2", so I am considered unusually tall. I am more than 2 standard deviations above the mean for height, so I'm unusually tall, but my height isn't an outlier. I'm not that tall. I'm not like, holy crap, where'd you come from? Are you even a person tall? But I'm unusually tall. Fair? So there are lots of places in between there, which is why we have different vocabulary. It helps, you know, depending on what we're looking at. Probably some of the biggest issues on this question came in just making sure, you know, everything's typed correctly and everything's added in correctly. As I said, there were a fair amount of these where it was really close, so it looked like it was just kind of a calculation issue, and I tried to give points for that. But also, I think one of the other biggest issues is, particularly with this standard deviation tool, making sure you go back to that mean, particularly since this question almost sneakily never asks you to find the mean. So it's often, well, 2 standard deviations, what do I have to add that to? All I've got is this IQR, and I've got these quartiles that I had to find. So I think people use either the median or the quartiles to do the 2 standard deviation rule, because that's the information you're talking about. But that standard deviation goes with the mean and nothing else. Fair? So. But questions about this question? Did that help? Was that
a lot? It's so easy. How could I not think about that? Because I got the second standard deviation wrong.
well? And one of the things I think that makes this question a little bit harder than it, you know, arguably harder than it has to be. It's just there's a lot going on in this question that you've got to keep straight. And a lot of stuff we'll find as we go along is like that. It's like, you know, we don't tend to do in here any individual calculations that are all that difficult. It's just keeping straight. What are we looking for? What are we doing? What pieces are we using? It's really easy to start mixing those together. So keeping your, you know, proverbial ducks in a row becomes a big issue. Anything else about any of that? Is it helpful for us to look at these? It does take up a fair amount of our time, but I'm seeing yeses from the heads I can see. Okay, I'm not going to spend too much time on these. There were a couple different versions of this question. One was flu vaccines, another was pass fail on tests. So I'll try to talk about those two in here. But these are tough, or can be tough to get right. So here, if you didn't have this version of this question, you want to know Arizona workers age 16 or older that travel to work, estimate the percentage that use the train to get to work. Your sample contained 500 Arizonians, workers age 16 and older. So what are your individuals? Your individuals are where your data is specifically coming from. So your sample, you sampled 500 people. So your individual is that individual 16 or under worker. So even things like this here, the individual, how people go to, or how people travel to work, that's what you're studying. That's like your subject. But the individual from which you're getting your data is your individual workers that are being questioned. A common answer to this question was people traveling to work, or workers 18, or workers under the age of, or sorry, not under, workers 16 or older. Workers 16 or older is your population. Your individual is an individual worker, a specific worker. Fair? So that individual's got to be fairly specific. When you're talking about the ones for flus, it was, and your individual was a particular person who got the flu vaccine, or for the tests, a particular student, or a more, or even better, a particular student exam. So your data is coming from, you know, individuals, from specific versions. Now it's possible if you say you were taking grades from different courses, like the pass rate from this class versus the pass rate from that class, that the individual is an entire group of people in that class versus the entire group of people from this class. So your individual isn't always a specific person. It could be a specific group, a specific time, a specific, you know, anything. But it's the specific smallest unit of where your data comes from. Variable here. Well, trains isn't a variable. Trains is a noun. But some common answers here for variable for the trains were things like what mode of travel somebody used to get to work. That's close here, but not quite. For the flu vaccine, it was, I forgot what some of the common answers were. But for here, your variable isn't how they got, again, how they got to work is close. You're just looking at the percentage of people that use the train. So your variable is really a yes or no. Did they take the train or not? Fair? So your variable is whether or not your individual took the train. Again, mode of travel is close, but if they said car or plane or bicycle or walked, none of those matter other than the fact that they weren't a train, right? So this is really train, yes, no. Sample, workers 16 or older. For this one, workers 16 or older, again, that's actually your population. Your sample is those 500 workers that were sampled. You're actually, you take a sample containing 500 workers. Your sample, the 500 workers. Fair? Population, your population here, always look back at your question statement. What do you want to know? You want to know how Arizona workers age 16 or older. You want to know how they travel to work. So what's your population? Arizona workers age 16 or older. Fair? So you had to be, at least fairly careful in how you answered that, to be real specific about that distinction between individual, variable, sample, and population. And it wasn't always, all or nothing, like that variable. If you said mode of travel to get to work, you got, got some points for that. You got a fair amount of points for that. But the more precise you could be, the more answers you got. There were, if you look at the points for that, there were more than 4 sections for points. That those had, so those were for me to kind of go, okay, how's the vocabulary use and whatnot, and also the biggest issue, complete sentences. This is a particularly bad example of none of those are complete sentences or even close to complete sentences. Do make sure you're answering in complete sentences. Fair? Questions about any of that? Again, if you have questions about, like, what would have been better answers for the specifics for your question, let me know. But we'll just look back over that and think about some of those distinctions. Again, it can often be a little bit tough. We're not used to having to put so much language and so much, communication and writing into our mathematics. But the more you go on in math, and particularly any of the fields you're going to use the stats in, being able to effectively communicate this information is one of the major points, both of this class and the study of statistics. If you can find all these statistical, values and all this information, but don't know how to effectively communicate it to others, then you're not, then why are you even doing it? So being able to effectively communicate this stuff is a big part of our job here. Frankly, you can actually make a career, it's called, loosely defined, called being an actuary. An actuary is sort of a statistician. A statistician, though, does the statistics work. A loose definition of what an actuary does is communicates that statistics work to other people. So you can get a whole profession that is just being able to turn this stuff into something that people who don't understand it can understand. And I haven't checked in about 5 years, but go back 5 years and be about 10 years previously, actuary was one of the most in-demand jobs around, because this kind of information affects everything that we do, but so many people can't talk the talk and don't know what it means or how it affects the decisions they make. So even just being able to clearly and effectively explain this stuff makes you a valuable employee, a valuable whatever. And again, flowers. Cool. Yeah. Anything else about all of that?
I have one quick question about the lab, if we can talk about that.
Lab 3?
Yes.
Somebody else was asking about that. Let me go,
Yeah, I'm number 2.
yeah, let me go grab that. Chapter 4 overall on, what do you call it? I should know what you call it. On regression and modeling. I mentioned this I think the second day of class, the first or second day of class. Chapter 4, most of you guys have that in your background in one way or another. So I'm not planning on talking too much about, I'm looking it up while I'm talking. That's why both of those aren't going well. Most of you've got that in your background somewhere. So I'm happy to answer questions about chapter 4, but I don't plan to talk about chapter 4 much outside of things that you guys ask and want to bring. So, please, if something comes up from chapter 4 or the lab, obviously, that we're looking at, let me know. But I'm going to start talking about probability on Wednesday and just go right into that. Oh, that's lab 2. Brought the wrong lab, sorry. I will find it. Yep, that's lab 2. I should just go to the calendar. Okay. That lab 3?
Yeah. I just had a question about question F, actually. So it asks how good is the association between the two variables. That is asking about if it's negatively or positively associated. Is that correct?
No.
No. Okay.
No. Negatively and positively associated is really just the direction of your association. So if your data looks like it goes up overall, that's a positive association. By positive association, that's not positive in the good versus bad argument. Like a positive association isn't a good association. A positive association means that as one variable increases, the other variable also increases. Fair? And you can think of it like a slope. It's a positive slope. Fair? A negative association or even a negative correlation, it's not bad. It just means that as one variable increases, the other one decreases. That's a negative association or a negative correlation. Fair? So it having a positive or a negative, and when you look at your correlation coefficient, it being a positive correlation coefficient versus a negative correlation coefficient, both of those are fine. It just tells you the direction of the correlation, not whether it's a good association or a bad association. Good and bad associations are really about how well that data fits your model, or how well. Let's see if I can make this do what I want to do.
Oh, so is it like asking about how well that R value, or how close to 1 that R value is?
That is exactly what it's asking, and almost all that it's asking.
Okay.
So if your values are really spread out, but more or less heading downward, like these values are more or less decreasing. They're kind of all over the place. But as we go in this direction, as we go in the positive X, they are dropping. So they have a negative correlation, a negative association, but not a real good one. If I ask where's the next dot, well, it could be up here, it could be down here. I don't know where it is, but it's probably not going to be up here, right? Because it looks like it is overall kind of going downish. So negative correlation, but not much of one. So that would be a fairly bad correlation. And your R value would reflect that. The R value for that last one would probably be somewhere around, I don't know, 0.3, well, negative 0.3 or so. But if instead your data looked more like this, then I ask you, where's that next data point? You probably say, oh, yeah, it's probably somewhere around here, right? Still negatively correlated because it's downward. But because our association is good, our next prediction will probably be fairly accurate. Fair? And numerically, visually, we can tell that by just looking at the dots and going, they look kind of liney-like. If you will allow me to use the technical term liney-like. It's not a technical term, by the way. These are the jokes. But in calculation, you're absolutely right. That is that R value. That R value, it doesn't have to be close to 1 or negative 1. Its absolute value wants to be as close to 1 as possible. So if that R value is 0.99, 0.98, 0.95, those are good correlation values. If it's 0.87, 0.86, 0.85, you're starting to get a little bit, really in a lot of practical applications, anything under 0.85, you're kind of going, okay, that's not great. You know, it might not be bad or horrible, but it's, I'm kind of just starting to go, okay, I'm not going to, bet the bank on this model. If it's 0.3, 0.4, 0.5, that your model's crap. Not to put too fine a point on it.
Is it like saying that roughly below 0.85, the values become more uncorrelated? So
Yes.
they don't have much influence on each other?
Yes. And what kind of correlation coefficient you want depends on what kind of data you're using. Sometimes, there are people who would see a 0.5 correlation and go, yay, that's more correlation than I've seen in any kind of my information. But if they're like, and I predict my next value will be, this, you're going to go, okay, good luck. Let's go find out. So depending on what you're modeling, your expectations of how good of a model it is, depend on what your data is and what you're studying. If you're, launching rockets, you've got like 4 data points and you're hoping they're close, But if you're trying to, do, what engine vibration in a production model engine, that correlation had better be 0.99 or you're fired, So it really does depend on what you're modeling. Fair? If that makes sense. But yeah, that question, how good is your association, is an R value question. It's a correlation coefficient question, plain and simple.
So for my question, it was on the instructions side of the page.
Right.
So specifically, I got my hands on some Pew Research data. My question is, I want to use age as one of the variables, but there's only 4 or 5, depending on whether you count or refuse to answer, X's, 4 age ranges.
Okay.
So I was wondering if, when you say with at least 50 elements, if you mean 50 unique elements, or if just 50 data points is enough, because I have 12,000 data points.
Which is more than 50.
Yeah.
Yeah.
So I'm wondering if the age range is a problem.
Nope.
Like, do I need to find? Okay, so I can use it. Good.
Yep.
Awesome.
Your scatter plot's going to be a little probably on the boring side.
Yeah, just
So more, data that's more like that is discrete data because you're separating it. So your scatter plot and trend, it's not the best type of data. It would have been better if your data wasn't put into those ranges. Before,
yeah. Unfortunately, I can't control Pew, but
yeah. And that's common
otherwise
online.
is exactly what I want.
Yeah, that is actually really common online. It's hard online to find raw data. Usually you find data that has been messed with in some way. Somebody has done something to make it more palatable. They've broken it down into frequency tables. They're giving you descriptive statistics. They've classed it in some way to make it not just a big raw pile of data. So often when you are looking online for data, that's a very common problem. But it should work, Fair?
Yeah, and I appreciate it. It was I had to jump through a lot of hoops to get access to the data. I had to find a way to change the .sav file to an Excel file, and
Yeah.
Not pay $100 for the right to do that.
No.
I got to figure it out though.
There are some good sites that have some raw data on them. I used to have a list. I'll try to find that if it helps. But yeah, overall, that should be fine.
So I know we're kind of at the end of class and everything,
Mhm.
but as far as the homework that's due today, there's just one problem that I'm a little confused on how to do, and I've looked through some of the notes, and someone actually posted about it in the form, and then I just went through and it's like, yeah, I'm confused on this one too. So I don't know, maybe if
Is that the probability one or
it
the one
is,
from chapter 4?
it's the one in chapter 4.
Okay, the probability homework, I'm gonna move because I was gonna talk about the probability today. But we talked about the test instead.
Okay.
So before I forget, I'm gonna move that.
And then is the lab still due today as well?
Yes,
Okay.
but let me move that just to, while I remember.
For
But yeah, the chapter, go ahead.
for lab 2, is our data based on lab 1 data?
Or other data if you want.
Okay.
Use the data from lab 1, you can use different data if you want. So
Thank you.
the chapter 4, which question?
It's number 6.
Number 6. A lot of dots in these questions. Okay, there you go. Number 6. Okay, what about? What about number 6?
So when it says find the correlation coefficient and report it to the accurate 3 decimal places, I'm just a little bit confused how to find the correlation coefficient.
Okay, have you done regression on calculator?
Yes, the linear regression sounds super familiar. I haven't dived into it in this class, and I don't think I've done it in a little bit prior, but I have touched base with it before.
Okay. So I'll show you real quick how to do it on Excel, but very, very quickly, because I know you guys do have to go and I need to talk to somebody before my next class. But if you go to the math department website, so just really quickly, I'm going to go to faculty and departments and mathematics to get to the mathematics department, or you can just search mathematics. Near the bottom here is some graphing calculator help tools. There's one on regression. That's a very, very good video on how to go through regression. If your calculator doesn't automatically tell you correlation coefficients, it'll show you how to put correlation coefficients on your calculator. Very, very nice video, goes through every bit of it.
Okay, awesome. Thank you. Yeah, I remember now. It's like inputting it into the calc. Yeah, it's been a minute. Thank you.
Sure. If you're looking, Excel also does it. Where'd it go? Oh, it's there. Duh. Excel also does it. But it takes a couple of steps. They both take a couple of steps. So I'd have to paste it and then make a scatter plot. So insert scatter plot. Well, I want scatter plot of that data, so I better highlight it while I do it. Trying to rush, that's always bad. So that gives data. Just looking at that data, you go, that data is poorly correlated. And it'd be hard to tell if it's positively correlated, because this point down here makes it kind of want to be positive. But if you ignore that point, it looks more negative. You know, so that's an argument about it being poorly correlated. But if we highlight that data, add trend line, it'll make a trend line, and there should be display R squared value and display R value. So that'll display your equation and your R squared value at least. And I believe there's a way to get that R value. There used to be. Add trend line, linear. It's fun. You can do polynomial equations too, or logarithmic, or But there should be a way to get. They changed it a little bit since last time I did trend lines on Excel. No, they might just do R squared. You might have to do it on a calculator. I know there's a way for it to get regression, but you might have to use one of the other tools. I would do it on the calculator, apparently. But yeah, there is a way to do it. in Excel, but they changed.
Okay, awesome. Yeah, and I
That-
can play with it. I appreciate it. It kind of just gave me a refresh as to what it even was again. So
Fair. But yeah, you can see even this R squared value is tiny. This data is very poorly correlated. Okay. Oh, I got to go to that other class. So I'll talk to you guys later, and I do want to talk to somebody later, so I'm going to have to ask all you guys to jump out. Okay, have a wonderful day. I'll talk to you guys later. If something comes
you.
up, let me know.
Okay, bye.
And I'll check that out. Let me- Okay. Tamara, what can I do for you real quick?
So can you hear me?
Yeah.
Okay. So I'm having some anxiety with the testing thing. As you can see, I did really crappy on the test,
Mhm.
which I don't understand because I'm totally getting everything. With me being in the whatchamacallit for issues with what's that thing called? Where they help you.
Accommodations?
Yeah, is there any way that I can get like a little bit longer of a test period, or is that not allowed?
Yes, absolutely.
Okay, how do I do that?
If you've got documentation, which as I recall, I believe you do,
I'm already part of the whatchamacallit.
right. Just send me an email or a message that says, I would like to use my accommodations,
Okay,
in which case I will look them up and I can add that to your test time.
okay. I don't know what kind of accommodations I have because it's been like almost 2 years. Since
Yeah, I don't remember if you had time and a half or double time, but either way, I can look that up.
I just let me
put
know
that
if I
on.
need to do anything to do that.
You just
Right,
need to send me a message that says, I want to use it.
Besides that,
Nope,
like
that's
if
it.
I have to go through them to tell them that about the anxiety and stuff.
Nope, you shouldn't have to.
Like, okay, all right. I'll
And
email you right now.
if there is anything like that, I'll find that out as I look it up, and I can tell you
Yeah.
that this is what I need. That's what I need. But I don't think you should need anything. Just let me know, and I'll look it up.
All right, because I literally I literally didn't have enough time. I was getting it and I was doing it, but like I really,
Yeah.
my fibro fog kind of got to me, and yeah.
Yeah.
So if you could do that, and I'll send you a message right now.
Yep.
Thank you.
Sure.
Okay, bye.
Bye.